This will be our fifth video in chapter 2. Lesson 5 is all about percent of change. So let's start with some vocab. First vocab word is percent of change. And the percent of change is the ratio that compares the change in a quantity to the original amount. That definition confuses some 7th graders, and I can't find a better way to phrase it, but I'm going to give you an example really quickly. So let's say that you went to Kohl's and you saw a pair of sneakers that you wanted to buy and they were $60. And then you went back 3 days later and those sneakers were on sale for $45. Now, you're good math students, so you know that that means it's a $15 decrease in the price. But you could also talk about the percent that the price changed by. Okay, so this is actually a 25% discount or a 25% decrease in the price of the shoes. Okay, so we're going to talk about that today and how to solve for that. But you're not just saying, hey, I can subtract and find the difference. You're saying, hey, how do I compare that change to the original amount? How do I compare that $15 to the $60 that those shoes originally cost? Okay, and the formula here is going to include something that you're familiar with. Remember the triangle delta? So delta always represents change. So we would find delta, we would find the difference between those two prices, and then we would divide it by the original amount. And whatever you get from that division problem, we will then turn into a percent. Because this is percent of change, not fraction of change or decimal of change. It's percent of change. So now that we know that little bit of an example, let's see how that definition makes sense. It's the ratio, so ratio is a division problem, and it compares the change, the delta, okay, it compares the 60 minus 45 equals 15 to the original amount. So it would compare 15 to the original $60, and then we would do a division problem and turn that into a percent, and that's where I got that 25% number. I called it a decrease or a discount because that price was going down. Okay, so some quick examples here of what these problems might look like. You might see something like, hey, by what percent did X increase to become Y? And obviously there's not a lot of context with that because I just put X's and Y's in there, but that's what the problems will ask us. By what percent did this increase? Or it could look more like the one that I talked about here at Kohl's. A sweater originally cost $15, now it costs $10. Find the discount percent. So find the percent that we discounted the price by. Okay. There's another piece to this chapter, this lesson as well. It's called percent error. And percent error, the definition is a ratio that compares the inaccuracy of a guess to the actual amount. Okay, and again, this is one of those definitions that doesn't necessarily make a ton of sense until we talk about an example. So let's say that I had a jar in my room full of jelly beans, and there's all my jelly beans there, and I had people guess. And let's say somebody guessed that there were 150 jelly beans in the jar, but the actual number of jelly beans was 175. So to find the percent error, we would figure out how far away that guess of 150 was. So 175 minus 150 is 25. The guess was 25 jelly beans away. And then I would compare it to the actual amount, the correct amount of jelly beans. So that I would compare it to that 175. That was the correct amount. And then I would do the same thing as before. I would turn it into a percent. And I don't know this one off the top of my head. Let me just take a really quick look on my calculator because I do want to give you an answer to that. It would be 25 divided by 175, and that's about 14%. It ends up being 14.29% if I do a little bit of rounding there, but I'm rounding it to 14%. So what we would say is, well, this guess of 150 was pretty close. It was about 14% away from the actual guess, the actual amount. Okay. So there is a formula for this as well. The formula includes delta again, so there's delta. And you know that I found delta by doing that little bit of subtraction. I said, well, okay, how far away was our guess from the actual amount? So it's delta over the actual amount, or the correct amount. And you take your delta, you find your subtracting difference here, you divide it by the actual amount, and then you want to turn that into a percent as well. So we're doing some division, getting a decimal, and then doing D2P to make it a percent, just like I did in our example up here. All right, so let's do two examples. We'll show an example of percent of change, and we'll show an example of percent error as well. And actually, I think I skipped a slide in here. There is a piece from your notes that you'll see. We're not going to go over it in the video, but it asks you to compare those two formulas. It's question number 1, question number 2. I would like you to do those two pieces on your own. Okay, question number 1 and question number 2, it asks you how are they alike, how are they different. We'll talk about that in class tomorrow. All right, let's look at our examples now. This is an example of percent of change. So it says, on Joey's last math test, he got a 72. He was determined to bring up his grade, so he studied every night, and his next test score was a 90. By what percent did Joey improve his test score? So this verbiage here, by what percent did Joey improve? So we're talking about an improving by a percent. That's how you know this is a percent of change problem. By what percent did he improve? Or by what percent did he increase his score? So the formula is delta over the original. And that just means that we have to take 90 minus 72 and figure out what the difference is. So 90 minus 72 is 18. And then we want to take that 18 and we want to divide it by the original test score. So his original test score was the first one he took, 72. Okay, so there's our ratio. We want to divide to turn it into a decimal and then make that decimal a percent. So we drop the 18 into the house. I'm going to speed things up with my calculator. You would probably want to do this by hand. 18 divided by 72 is, oh, what a nice answer here. It's 0.25. Exactly, no rounding needed. We're not finished yet. We want to use D2P to change that to a percent. So move your decimal 2 places to the right, and we figure out that he increased his score by 25%. Okay, so not too shabby, not too bad. The formula is just there to guide you. Basically, we're just figuring out how far apart his two scores were and dividing it by the original score. All right. Last one, this is an example of percent error. We know this because it talks about error in the problem, so let's take a look. It says, example number 2, to win a prize at the block party, you have to guess the weight within 5% error of a fire hose. So you walk up to this fire hose and you guess how much it weighs. Leroy guessed that the hose weighed 125 pounds. The actual weight of the hose was 137 pounds. Was Leroy's guess accurate enough to win a prize? Okay, so basically we're trying to see if Leroy was within a 5% error of the actual weight of the hose. So this is a percent error problem. Remember, the formula for percent error is delta over the actual number. And again, this formula is just to help guide you. I would write it on the paper as you're learning it, but basically we just take the two numbers and subtract them. 137 minus 125 is 12, so Leroy's guess was 12 pounds away, but that's not how we find percent error. We have to take those 12 pounds and we have to divide them by the correct weight, the actual weight, and the actual weight was 137. So we would drop the 12 into the house, divide 12 by 137. I'm going to use my calculator to do that. And I'm getting 0.0875 and it keeps going. So if I want to round this, maybe I'll be a little more accurate this time. I'm going to round to the thousandth place. I'm going to have to use that 5 to tell me that I round the 7 up. So I get 0.088. That's not yet a percent. We have to do D2P, move your decimal 2 places to the right, and that means I have an 8.8% error. 8.8% error is pretty close, but it's not within the 5% that Leroy has guessed had to be. So no, Leroy was not accurate enough to win a prize. Leroy's guess was not accurate enough to win a prize. Sorry, Leroy. Okay, so you're getting the idea behind this. The formula does help. It is there to guide us, but if you're not using the formula, as long as you know the gist, you take the two numbers and divide them. For percent of change, you divide by the original. You take the two numbers and you subtract them. Then for percent of change, you divide by the original. For percent error, you divide by the actual number, and then you change to a percent. Go ahead and do your practice problems. Write down any questions you have for class tomorrow.